Hi everyone, so in this video we will dealing with the laws in calculating limits and how to apply these laws. So let's start with the four basic limit laws. So the first law is the constant law. So the limit of c as x approaches to a is equal to c. For example, the limit of 5 as x approaches to negative 3 is equal to 5. So the second law is the limit of x as x approaches to a is equal to a. So for example, we have this, the limit of x as x approaches to 2 is equal to 2. Okay, the third basic limit law is the first power rule. So it indicates that the limit of x raised to nth power as x approaches to a is equal to a raised to nth power, in where n is always a positive integer. For example, the limit of x squared as x approaches to 2 is equal to, diba, a raised to n. So 2, our a is 2 and our power is 2, so it will become 2 squared, and 2 squared is equal to 4. Okay, so the fourth basic limit law is the radical basic limit law. So it indicates that the limit of the nth root of x as x approaches to a is equal to the nth root of a. So for example, we have the limit of square root of x as x approaches to 4 is equal to the square root of 4. Diba? So square root of 4 is equal to 2. Okay, so those four basic limit laws are used in dealing with the generalized limit laws. Okay, the first generalized limit law is the sum law. So the limit of f of x plus g of x as x approaches to a is equal to the limit of f of x as x approaches to a plus the limit of g of x as x approaches to a. For example, the limit of x plus 2 as x approaches to negative 3 is equal to the limit of x as x approaches to negative 3 plus the limit of 2 as x approaches to negative 2. So applying our learning about the basic limit law, so the limit of x as x approaches to negative 3 is equal to negative 3, then the limit of the constant 2 as x approaches to negative 2, negative 3 is equal to 2. So we have negative 3 plus 2 is equal to negative 1. So the next generalized limit law is the difference law. So the difference law indicates that the limit of f of x minus g of x as x approaches to a is equal to the limit of f of x as x approaches to a minus the limit of g of x as x approaches to a. For example, we have this, the limit of x minus 2 as x approaches to negative 3. So it is equal to the limit of f of x, which is the limit of x as x approaches to negative 3, plus the limit of g of x, which is 2. So the limit of 2 as x approaches to negative 3. So use our learning. So we will use our learning in the basic limit law. So this is equal to, so the limit of x as x approaches to negative 3 is equal to the negative 3, and the limit of 2, this is a constant, so is equal to 2. So negative 3 minus 2 is equal to negative 5. Then we have the constant multiple law. So the limit of c f of x as x approaches to a is equal to c the limit of f of x as x approaches to a. For example, we have this, the limit of 3x squared as x approaches to 5. So we have the constant 3 times the limit of f of x, which is the limit of x squared as x approaches to 5. So 3 can use our learning of the basic law. So x squared, it is the power rule number 1. So we have this 3 times 5 raised to 2. So we have 3 times 5 squared is equal to 25. So 3 times 25, we have 75. So then we have the fourth one, which is the product law. So this law indicates that the limit of f of x times g of x as x approaches to a is equal to the limit of f of x as x approaches to a times the limit of g of x as x approaches to a. So for example, we have this, the limit of the quantity of x plus 1 multiplied by the quantity of x plus 1 as x approaches to 2 is equal to the limit of f of x as x approaches to a, which is the limit of the quantity of x plus 1 as x approaches to 2, times the limit of g of x, which is the limit of the quantity of x plus 1 as x approaches to 2. So using our understanding or learning of the basic limits law, so this will become the limit of x plus 1 as x approaches to 2 is equal to the limit of 2 plus 1. Then on the other side, the limit of 2 plus 1 also. So 2 plus 1 times 2 plus 1. So 2 plus 1 equals 3. So 3 times 3, it is equal to 9. And we have the fifth one. So we have the quotient law. So this law indicates that the limit of f of x over g of x as x approaches to a is equal to the limit of f of x as x approaches to a divided by the limit of g of x as x approaches to a. So for example, we have this. The limit of x 3x plus 2 over x minus 5 as x approaches to 1. So we have the limit of 3x plus 2 as x approaches to 1 divided by the limit of x minus 5 as x approaches to 1. So it is equal to 3 times 1 plus 2 over 1 minus 5. So we have 3 times 1, 3 plus 2, 5. Then 1 minus 5 is negative 4. So we have now 5 over negative 4. So let's proceed to the sixth one, so which is the power rule or power law number 2. So this is considered number 2 because we have power rule number 1 in the basic limit law. So this law indicates that the limit of f of x raised to n power as x approaches to a is equal to the limit of f of x as x approaches to a raised to n. So where n is always a positive integer. So we have here, for example, we have the limit of the square of x plus 1 as x approaches to 2. So this is equal to the limit of x plus 1 as x approaches to 2 raised to 2. So we have here 2 plus 1 raised to 2. So this is equal to 3 squared. So 3 squared is equal to 9. Let's proceed to the last one, which is the radical law. So this law indicates that the limit of the nth root of f of x as x approaches to a is equal to the nth root of the limit of f of x as x approaches to a. So we have, for example, the limit of the square root of 4x as x approaches to 4. So it is equal to the square root of the limit of 4x as x approaches to 4. So this is equal to square root of 4 times 4. So square root of 16, it is equal to 4. Okay, that's all. Thank you for watching. Keep safe, everyone. Bye.